Okay, we are going to look another problem number 88, merge sorted array. And this is the problem we are going to solve using two pointers technique and going to write algorithm in Python. So what is asked here? Here we have given two integer array nums1 and nums2 sorted in non-decreasing order, and also given two integers, integer m and integer n. And these integers are representing the numbers in nums1 and nums2. M is representing the numbers of element in nums1 array, and n is representing the numbers of element in nums2 array. Okay, and what we have to do here is we have to write an algorithm that will produce an output, and the output will be a merge of this nums1 and nums2 into a single array sorted in non-decreasing order. Okay, and it is also given in the problem that the nums1 can hold, that is, can accommodate all the elements of nums2. Okay, this is very useful and important information. All right, so basically the length of nums1 is number of element in nums1 plus number of elements in nums2. Okay, so let's see the example. Let's see the example 1. It is the input we have see here is nums1, which is 1 2 3 0 0 0, and nums2 is 2 5 6, and you can also see the m equal to 3 and equal to 3, right? And the output what we are expecting is 1 2 2 3 5 6. Basically all the three elements from the nums2 are merged to the nums1, and it also sorted. Okay, and similarly if you see the example 2, nums1 has only one element, nums2 has nothing, so we just need to return the nums1. And the third one is nums1 equal to 0, nums2 equal to 1, it should only return 1. Okay, this is the constraint we have. The nums1 dot length is equal to m plus 1, m plus n, and nums2 dot length is n. Okay, so this is given, and what we have to do is we have to solve this problem using the two pointers technique. The two pointers techniques, why we are saying is because we were talking about the two pointer techniques, and we will see how efficiently we can write an algorithm using the two pointers technique and produce the output result with time complexity on and the space complexity is O1. So let's get started. Let's see how this looks in the pictures. Okay, here the pictorial representation of those two arrays. The first one is my nums1, this is my nums2. Okay, and obviously, right, we are going to use the two pointers technique to solve this. So what we're gonna do, we have two inputs, number one, nums1 and nums2, and we also given the m, which is the length of the first, and is the not length, sorry, the elements in the first one, and the n is the elements on the second array. And it's also given that the length of nums1 dot length is m plus n. Okay, remember it is given that we don't have to create a new array. Instead we just need to place the numbers of element in nums2 into the nums1, right? So, and then making sure that this the nums1 is also end up in the sorted, so the output should be 1, 2, 2, 3, 5, 6. That should be the expected output as. So using the two pointers technique, what we're going to do is our pointer 1 is going to point to the first element or last element, or we can have the pointer 2 pointing to the first or last. Like, this is something we have to decide where we gonna initialize our pointers, right? If we're gonna initialize the first, okay, what happens is we are going to compare the first element and with the first element in the nums2, and then placing them in the first. But again, right, that is not more efficient. As you can see, the last three elements is already 0, okay, and we also know all the elements in nums1 and nums2 are already sorted. So if we compare the last elements in both the array and see which one is greater and start placing them from the back, right, then surely we are placing them more efficient instead of starting from the first, uh, beginning from the start of the array. So what we're gonna do is we're gonna initialize the pointer 1 at the end of the first array, which is the m, right, m minus 1, and the second array should be my pointer 2 is gonna be n minus 1, that is pointing to the last element in the nums1. And when I compare the last element of both the arrays, I can see that the sixth element is greater than the 3. So I know in both these arrays the sixth element should be placing in the last here, right? So I need another pointer which will keep track how I'm adding the numbers. So this will be my pointer 3, and that will be m plus n minus 1. Okay, so I initialize the pointer 1 to the last element in the nums1, and the pointer 2 will be the last element pointing to the last element in the second array, and we are comparing this, and whoever is greater we are placing in the end of the array in the nums1. And once I place, right, for example, my pointer 2's value is greater, then I'm going to move my pointer to the next element here and comparing it with the other way, the same pointer 1 values, right? So here again 3 is less than 5, so my 5 again going to the next place in the nums1, and again I'm going to move my pointers to the second element, and then I will compare it again with 3. So 3 is greater than 2 this time, okay, so I'm going to move this 3 to this place, and then since I place the pointer 1 value, I have to move my pointer 1 to point to the next element in the first array, and then I will compare. Since both are equal, we gonna place the remaining in the nums1 at the place here, right, and that will be it. So by placing these numbers at this position, we have achieved the desired result, and very efficiently. So let's look how we going to convert the problem into the algorithm, right? So what we have seen, we need 2 pointers. So pointer 1, which is going to point to the last element of my first array. Pointer 2 is going to point to my last element in the second array, and also I need a third pointer which I will say merged or I will say, let's say pointer 3, which is the last element the of the nums1, right, where we're gonna put the highest, the greatest number. All right, now I am going to loop, and I'm going to loop and finding I'm going to loop from the pointer 3 till the first element, right? I'm going from the backward to the front, and I'm making sure the first step, like if my pointer 2 has nothing, right? So if my pointer 2 is less than 0, pointer 2 is less than 0, then I can simply break. I don't have to do anything, right? Similarly, if pointer 1 is greater than or equal to 0 and nums1 is at pointer 1 is greater than nums2 at pointer 2, then we have to place the pointer 1 value at the end. So I will say pointers that equal to nums1. We are not creating a new array, so nums1 pointer 1, and we have to move our pointer 1 to the next element, right? Similarly, if this condition is failed, that means my nums2 array value is greater, then I will do the same, like I'm going to place the nums2 value, okay, it nums2 pointer 2, then I need to move my pointer 2, and I think that's it. So this is exactly what happens. We need 3 pointers. The first one is pointing to the last element of in the first array. Pointer 2 is pointing to the last element of the second array. Pointer 3 is the total length of the first array where we have to merge, and then we are starting from the last. We are using the pointer 3 and looping through the element in the nums1 and nums2 and making sure that the values, okay, is greater. Which value is greater? We are checking these pointer 1 and pointer 2 are pointing to two values in this two different array, and which one is greater, we are placing them at the right place in the first array, and that will be it. So let's run this. So I'm exiting this screen and let's run this, and we can see that it is accepted, right? It is producing the result what we are expecting. Since we are looping through all the element of the first one, right, we are looping through the pointer 3, which is m plus n minus 1. So the space time complexity is on, and we are not creating a new array, we are just placing this numbers into the first array, and it's called merge, right? So the space complexity is open. Beautiful. Thank you for watching.